In this video, I'm going to show you how to solve quadratics by factoring. And there's a little bit of our words cut off here, so I'm going to read that for you, what it should be, what it should say. A polynomial is in factored form if it is written as the product of two or more linear factors. And according to the zero product property, the product of two factors is zero only when at least one of those factors is zero. So what we're going to do is solve our quadratic equation, and what we're going to do is find the values of x that make our equation true. And these can be referred to as many names. And so if you hear your teacher say these names, this is what they're referring to. Zeros is one of the words, roots is another, solutions is another, and there's actually one more. It's an x-intercept. And so when we are solving a quadratic, we're actually looking for two important pieces of our graph. Now, if you have a quadratic, that means that your highest power is a 2. And what we're going to do is find up to the two solutions or zeros or roots that your picture has. And we're not going to graph it yet, but a parabola looks generally like this. But if I were to move that parabola lower, it would have up to 2 places where your parabola touches the x-axis. And what we're going to do is find what those two numbers could be. Now I'm saying 2 because your degree is 2, but that means you can have up to 2 zeros or roots or solutions or x-intercepts, whatever you want to call it on your graph. And so what we're going to do is solve by factoring, and how we do that is by setting each factor. So notice how there's 2 factors here. We're going to use the zero product property and set both parentheses equal to 0. So if this is x squared, x times x, if we set this equal to 0, that means one of those factors had to be 0. So x could have been 0, or your other x could have been 0, which is why you see only one intercept, and that's going to be at 0 for our parent function x squared. But if we move our graph up, down, left, or right, your zeros are going to come in different locations. And so what you do is you set each factor equal to 0. So we're going to set the factor of x plus 7 equal to 0, and we're going to set our x minus 4 equal to 0. And we're going to solve for x. And our two zeros, or you might call it a root or a solution or x-intercept, in this case would be -7 and 4. And so those would be our two places, our two intercepts where our parabola would cross our x-axis. And then that helps us to be able to graph it, which we're going to do in the future. And so the first thing when we're solving by factoring is to talk about the easiest kind, which would be when your polynomial is factored for you. And so it makes it pretty easy to solve because you just set each factor equal to 0. So I'm going to set x minus 3 equal to 0, and then an x minus 4 equal to 0. And we're going to solve each factor by getting our x isolated. And so in this case, x could equal 3, and our other solution is going to be at +4. Now we're not going to graph these yet, but we will in our next unit. And so for right now, I'm just going to have you stop here with what your solutions are. Now here, one of my factors is the variable x, and my other factor is an x plus 10, and we're going to set each of those equal to 0. Well, this one is already solved. I don't have to do anything to get my x alone, but for my other answer, my other solution, or root or 0, would be at -10. Now here, our factors are just slightly more complicated. If I have 2x plus 3 set equal to 0, and an x minus 6 set equal to 0, one answer is going to be +6, and another answer here, if I divide then by that coefficient of 2, is going to be -3/2. So sometimes you won't get a whole intercept, sometimes you'll get a fraction, and that's okay. So now I'm going to set for this problem each factor equal to 0, and we're going to solve both of them. So I'm going to subtract 2 here, and then divide by 5. And one solution is at -2/5. And my second solution, when I solve for x, divide by that coefficient then of 3, will be -2/3. Okay, now this factor I noticed had a GCF of a 5 in the front. Now it is not going to make sense to say that 5 equals to 0. So if there's no variable, you don't solve that factor, because it doesn't make sense to say that 5 equals 0. So you're actually going to ignore that factor because there's no variable to solve for that factor. But I will set my 4x minus 3 equal to 0 and a 2x minus 3 equal to 0. And we're going to solve both of those. So I'm going to start by getting my x term alone by adding 3 to both sides. And then I'll divide by that coefficient of 4. So one solution will be 3/4. And let's solve for the other one here. Add 3 to both sides to get your variable x alone, and then divide by that coefficient of 2. So we have 2 solutions, one of 3/4 and one of 3/2 for this one. And here's one more. Notice how this GCF that was out in the front does have a variable. We will solve for this one because it has a letter here. So divide by that coefficient of 3. Now 0 divided by anything is 0. And here, x plus 1 equals 0. I'll get x equals -1. And then 2x minus 5, set that equal to 0. I get 2x is equal to 5, and then if I divide by that coefficient of 2, I get an answer of 5/2. Now in the next video, I'm going to show you some examples where our polynomial is not already factored for us. So I'm going to show you in the next video how to just kind of review factoring and then set your factors equal to 0.